Welcome to the 18th Gardens and Grows workshop for 24th September 2017. As usual, we'll just run through the options to register for the private agricultural teachings there. It's Dr. Gatwa, as well as getting hold of the books. It should be printed soon. All right, today I'm going to give some feedback on your presentation there, Alex, as well as looking at the amino acid formation on Earth, look at sort of the hydrogen and helium and that whole nitrogen story in terms of the creation there, as well as that question we posed last week in terms of the crown shyness of the trees. So I'm going to start off with Alex and what you had presented last week with us. Now, for those that I'm just waiting for the pictures to come through. Okay, for those that weren't here last week, Alex had shown us his reactor, and it's essentially the six, if you look at the photograph on the left, it's 6 bottles filled with different amounts of Gans, and he's placed those in that formation, and he placed water around there, and he started measuring the pH of the water before he put them near and around his reactor and afterwards. So he went into great deal of detail on how he changed the pH of his water through his reactor and the environment that had changed. So we also done an experiment, Alex.
Okay.
So we had, with your shape there, I think what you presented last week was very, very profound. I got a lot out of it, so I really want to thank you for that one. Because, you know, we've also made a lot of Ganses, and we had all these Gans bottles essentially sitting in a row. And then Lisa started playing with them and putting them into a different formation like this. And one can immediately feel the difference where putting them in a bit of a formation, that together they became a lot stronger than just a lot of them sitting in a row next to each other. So we had also got a little bottle of water, purchased a bottle of water and tested the pH at 7.2. And that was 40 hours later, it had changed to 8.1.
Oh.
So that was quite a change. You know, obviously that's right in the middle of the reactor there.
That's significant.
What we had done, let me just go back one. Now this is just a normal, at least had put a collection of the different Ganses. So we've got, wait, I'll just wait till we come back. So we have got CH3, CO2 in the middle, there's zinc, calcium, Gans, copper, Gans, folic acid, and then the bottom one was gold and silver. And so it was just in that formation. And it was to say we could feel that energy coming from that formation.
It's like a heat. It's like a dome of heat around that whole area, quite strongly to about 0.5 meter away.
Wow.
So there was the change. What we're doing now is we've got some
soda water,
sparkling water.
Yeah. We've tested it. It was 4. The pH was 4. So we're going to see if I can make soda water that's alkaline, which should be quite a good way to drink soda water.
Yep. So essentially what you've done there, Alex, obviously you're creating a flow which increased over time. As you said, the more water you added, that became more alkaline, and so it just built and built and built. And this flow, that's what really got to me. Is, you know, we see a lot of the stuff and we read a lot of the stuff, but until, you know, you see a demonstration like yours, an experiment like yours, only then does sometimes things click into place. And so what came to my mind was this, exactly the same as, sorry, waiting for a picture to come through.
Not changing. There we go.
We're getting the same type of flow on the plants with the leaves, because each leaf contains the Gans. It's Gans in that leaf, different. And so we're also then obviously creating the flow, different flows between the different leaves on the plants as well.
Does that make sense?
Absolutely. I had stolen the idea from a daisy.
Okay. Oh, there you go, eh?
Nature will guide the way.
Yes, yes. Can I make a comment on the arrangement of the bottles there, Lisa?
Yeah.
I took your advice. I did put CH3 in the middle, so now I have 7 bottles. But I didn't want to do a very, very strong field, so all I did was I did have a bottle of CH3 Gans, and I just drew off the plasma water. I didn't put any Gans in the bottle. I was just a little bit, I'm still a little bit leery, but I did want to create more of a vortex in the middle, and so I just took the plasma water. That's it. So now I have 7 bottles in the middle of the reactor. I didn't notice an immediate effect because it was a very gentle effect, but about 3-4 days later I did. And simultaneously I've upped the number of cases in the reactor to about 13. That's about as much space as I have without bringing down the Tower of Pisa. But yeah, I don't know about the heat aspect of it. I haven't had the opportunity to experience that. But as far as the energy field is concerned, people are hanging around. They get into the field and they don't even know they're in the field, but they just like to hang around and just feel good.
Okay.
And I know that I'm feeling very, very good. It has made some effects on me. So I love the little pictures, the little arrows that you brought in there. That is terrific, and you're going the right direction as far as I'm concerned too. Just one other thing, I am running an extreme pH test as well, but I was extremely acidic. And so, you know, if you do the math, I'm finding that I'm really asking the pH to go up a factor of a million. I don't know if the reactor is strong enough at this point to do that. You know, to go up a factor, 1 order of magnitude or 2 orders of magnitude. You just went up 1 order of magnitude, and that's perfectly reasonable and perfectly easy to do. And you did it in about 40 hours.
Yeah, 2 days really.
Well, yeah, it was like overnight, and then, yeah, so it was from the evening to the following evening to the following morning. So 36 hours. Yeah.
Well, if you put more water in there, you'll have a stronger field, and then of course it'll last longer. Can I just ask you, why you didn't put the CH3 in the middle?
Actually, I just shifted the bottles because those were my display bottles that I had for my workshops, and they were just literally in a line on my top of my one sort of cupboard. So I just shifted them out of the line and created this, you know, the 6 with the 1 in the middle, and I did it randomly. The only thing I did was I put the smaller bottles in between the bigger bottles because I've had some big bottles, some little bottles. So, and I'd chosen those specific Ganses purely on the pretty colors.
Well, I think if you take your own advice, switch the CO2 with the CH3.
I'll do that, yeah.
And the small bottles in between the big bottles, that is huge. That's a brilliant design. I love it. And also the spacing. I noticed that you've left a gap between all the bottles.
Yes,
right?
yeah, I do think it needs a gap because I
Yeah.
think they need that, you know, to the sort of connection point between each field in the center of each one. So they need to be separate. But it's what I've managed to do. Although I chose all the different pretty colors as a display, all the ones I've got there are compatible with the body. So the calcium GANs, the folic acid, these are good for the body as well. And I find that the gold and the silver GANs is quite a strange one because it feels very good when you hold it. And the energy healers that I've had feel it, tell me it's got a pulse on its own as well. So it is a pretty strong field. And it's the most beautiful purple color. It's gorgeous.
Oh, that's great news.
So yeah, it's at least it's confirmed exactly what you had done, and I think it's a wonderful way to do things. I'm just trying to figure out now how to create something that one can teach people to make easily, because to make this amount of GANs and do this would be quite a job for a person to attempt. It's you know, it would be easier if one could do it on a smaller scale, but I just don't know what is too small to create a decent field and how we can strengthen the field. So I've got a few ideas that we're toying around with to sort of add energy, and we'll see how we go.
Right. This picture with the world plant in the middle there, I think you'll notice that if you get a bunch of plants together, that they create a momentum on their own, and the positioning of the whorls, or of the emerging buds, if you will, the positioning of them, I think you'll find that they'll be in a similar construct, but you will find that the energy will build up simultaneously as they come around, which kind of explains why sometimes you'll have a weak plant and it'll take a while for it to get some momentum, and I think that's exactly what it is. It's just the plant becomes its own reactor, and then actually creates its own field and grows into its own field as a result of the reaction there. But again, the arrows that you have on the world plant, those are really interesting. I'm hoping that you would elaborate on the other two. I'm not really seeing the rotation on the opposite one, the alternate one. I can see that somewhat.
Well, I think it's I just put the arrows there because, you know, we don't know what sort of rotation, but there certainly would be flow between the leaves because they're not all the same size as they grow. So, you know, whatever flow is there, it's creating some flow. So what it is, I don't know. I just put those arrows in there just to indicate that there would always be this flow between the different leaves.
Yeah, for sure. The bushy plants will reflect it much better than the long stem plants.
Yes. Yeah. But I have noticed what you're saying, that plants, you know, when you look at little plants and seedlings, they get to a certain point and then all of a sudden they just take off. And yeah, I often thought that they reach a certain point where maybe there's enough surface area of the leaves and that, and then boom, they just take off.
Yes.
And there's enough there.
They seem to have enough gravitation to start pulling in the fields that they need.
Right.
And I think that's why when you grow seedlings and you don't feed them properly and they're lacking, that's why they never create really good vigor, even if they get older, because they haven't gotten that strength within themselves to gravitate the fields into themselves. Right.
Just as another follow-up, I had some myrophyllum. It's commonly known as parrot's feather. And so what it is, it's a long, thin stalk again, but it does have individual little bristles on it. and there clearly is a rotational pattern within the plant as it goes up along the stem. But they have also taken off. I've been a little bit more observant of the other plants, and I'm just seeing a uniform kickstart on all the plants around, and I just don't have a lot of space in the experimental area there, but everything that I have there is just growing marvelously. And the other thing is the peace lilies. Like for me, a peace lily is a water plant, and I'm just getting massive leaves coming out of that plant. And I have one that's about 3 years old, and it's been sitting in an aquarium, and it is about 4 feet tall. But the leaves are just popping up every week on that, and they're really a brilliant green. So, yeah, I agree with what you're saying there, Lisa.
Good. Yes. Thanks for that, Alex, because you certainly made some interesting observations. Thank you.
Well, thank you for bringing up the follow-up there, Jim, because there has been quite a lot of extra activity on this side. So
yes.
We can talk about that weeks down the road and see how we progress.
Yeah, wonderful.
Thank you.
Okay, if we looked at, I posed a question about this crown shyness and whether I'm going to show you a picture of what it is, and then I'll come back to the definition.
We just have a really slow internet tonight, so the pictures are taking ages to get through.
So essentially what this crown shyness is these are sort of a forest of trees, all similar trees, and what they're doing is they never really touch. They create a gap between them, so that outer canopy of the trees create this huge...
It's a beautiful pattern, but yeah, only certain trees do it, not all trees. Obviously, because all the trees I see in my garden don't do this.
No. Right. Okay, so any ideas on what might the reason be from a plasma point of view? Any takers? Nobody will be wrong.
The reason why there's the spacing between, I've got to put my phone down, I can't hold it. The reason why there's the spacing between the trees.
Yeah.
Well,
and it's just at the top of is what they call the crown of the tree.
God, that's a beautiful pitch. That's amazing, isn't it? That is without doubt plasmatic fields that are keeping them apart from each other. When because when I'm in the understanding that when plants they touch each other, they tend to it causes confinement to them, so to speak. You know, they feel maybe constricted or like in a sardine can or something like that. So maybe the fields that they're giving off is literally just, God, it's amazing. I love that picture so much.
It looks phenomenal. Like a brain.
It does. It's totally taken my breath away. That is it's just phenomenal. I feel that certainly that they are they're not pushing against each other because they don't want to impede on each other. I don't really have very much more to add on that. I'm sorry.
No, it's a you know, it's something we're just learning about. I just saw a picture, and I just thought, oh, that's quite. I also love the picture, and I thought maybe we could try and sit and explain that. That was Wikipedia's version of why they crown shyness. So I said the phenomenon is most prevalent among trees of the same species, which you can see in the photos, but also occurs between trees of different species. There are many hypotheses as to why crown shyness is an adaptive behavior, and research suggests that it might inhibit spread of leaf-eating insect larvae. So
I don't think that's the reason. I think it's more a case of we'll have to ask the souls of the trees why those specific trees don't want to connect with one another and why they need their own space.
What came to my mind was, if we understand that each tree is its own reactor, and so that space, if we create two spinning balls and that space in between is where we're wanting to create something, then are these trees not positioning themselves like this so that they can create something different that they actually need from the environment? So that in those gaps, those spacings, they are creating certain type of field that they need. So that was my thinking.
Can I jump in, Jim?
Sorry?
Can I jump in?
Yes.
The tips of the leaves are all negatively charged, so they're all the same polarity, and then like poles repel. So that's where you get the uniformity.
And from a plasma point of view?
Well, the direction of the flow goes right up the shaft of the trunk of the tree.
Yeah.
And so then it comes out at the top. So, gee whiz, medicine and agriculture has never recognized the Correllian effect.
Yeah.
And so the flow definitely comes up the trunk and then out from the tips of the trees, and that's why you see the branches, the way they go from a thicker to a thinner to a thinner to a thinner, and then once they get to the outer extremity, but based on surface to volume ratios, the tips of the trees are negatively charged. So when the two come together, then they would repel. The interesting thing about this particular picture is that these are all mature trees, so the canopy is at a uniform height. So it actually shows on a plane, on a flat plane, like a pancake. The canopy is like a pancake there, so we can see kind of in two dimensions that there is a gap between them.
Yeah.
The shorter trees, they'd have to be at the same height. So younger and shorter trees are not going to have that same effect. So
no.
This is a unique effect in mature trees only. But yeah, clearly it shows that there's a repelling at the top of the trees, and you know, you have the same thing at the tips of your fingers. That's why your fingers spread out, you know, from your hand.
Yes.
What prompted you to ask this question?
I just saw the picture and I just, you know, I looked at the definition there in Wiki and I just thought, no, that's not right. So I just thought that, you know, that it's an interesting question. You know, we have to look at everything now in nature and from a plasma perspective as to why things are the way they are. So it's just to stimulate the brain.
Well, I did my homework. I went and checked this out on Wiki, and I was absolutely disappointed with the answer. And it's the same answer that you just came up with. You know, and I just really don't understand why they don't understand this thing, because it's right there in plain sight. You can clearly see that it's uniform. I mean, how do you do that? You know, you can't get your kids to clean up their room as neatly as these
No.
kids are using the canopy, you know.
We ask too many questions, you see.
Well, you know, like these pictures are beautiful. Yes, like the gentleman said. So it's a really unique thing. But that's where you see the beauty in nature. So I don't know. What do you think about my answer?
Well, that's it. Yeah. As I said, I have no idea myself. Anything is possible. I think there's a whole lot of issues here that, so it was just to try and get us thinking in that plasma way.
Excellent.
And I think if we start taking photos with special cameras and finding out ways to test these fields, yes, we probably find there is a reason, but yeah, and why only certain trees of a certain maturity do it. And whether maybe it's just because they don't want to compete for the sunlight, or whether they literally, you know, need something specific that is generated between on the coulombs barriers of each of their leaf areas. I don't know.
Well, you said like the species. I was going to say that there aren't any species in Canada, because I was looking. I'm right in the bush, and I was looking at all of that, and I'd never seen anything like that. And when I did check on Wiki, apparently in the province of Alberta, we have those kinds of trees, and that's the only place that we have it. And so it's not visible in all the species. These particular plants have like a hat. Right?
Yes.
They grow tall and slender, and then they have a hat on top.
Yeah.
So all these hats are at the same level, and so because of negative charge, they're repelling each other. That's the way I see it.
Yeah, maybe they also work together to create this huge network, this huge reactor at the top, you know, at that certain height, to interact with the fields. So.
Well, they are casting shadows, aren't they?
Yes.
It's like an umbrella.
Yeah.
But they're all working together. How did you do that? How did you do that? How did you get them all to work together like that? That's so cool.
Because, you know, they're only stupid trees. They know nothing.
I know. That's great. Yeah.
Okay, so we'll leave that one for the question mark. Maybe we'll find our answer one day when we learn a bit more. Okay, so we have done this before. I'm just going to do a bit of a refresh, and then I'm going to go into a bit more detail on it. So,
you're going to have to really be slow today.
Okay, the process of life on this planet depends on one factor, which is the position of the Earth in relation to its position to the Sun. And we know that the interaction of the fields from the Sun and the fields from the Earth leads to the creation of plasma of nitrogen in the upper atmosphere. So any changes to the magnetic fields of Earth or to the Sun, or any of the position changes, then we change this condition. And we will then have no life as we know it today, or slightly different life because of this changes in the conditions. So it's just a case of Earth's position to the Sun, and at that point, with the field interactions, we have that nitrogen that is created in our upper atmosphere. Now, essentially, in one of the workshops, Mr. Keshe has explained nitrogen has residuals, combinations, and divisions. And I'll try to explain those three terms in it. And nitrogen is the creator. So what you're saying is the nitrogen and other fields from the Sun interact, and due to the friction, it releases hydrogen or helium. Okay. And essentially the nitrogen losing fields will become carbon, and nitrogen gaining fields will become oxygen. Bear in mind, this is all in the field-based plasmatic field state, not in any oxygen or gas state. So the carbon and oxygen are created from the mother nitrogen. Therefore, they'll have the connection and that's why they stay together. And out of this interaction, the plasma of hydrogen is created as well as from the sun in outer boundary. So we have nitrogen to carbon, nitrogen to oxygen. So there we have the basis for the formation of our amino acid of nitrogen, carbon, oxygen, and hydrogen, which is in a plasmatic form, and with the addition of salts leads to the creation of amino acids. So the role that each one of these amino acids play is the oxygen plays the gravitational, nitrogen is the creator, because from the nitrogen we can get carbon or we can get oxygen. I'll go into details on that one later. And hydrogen we know is the energy. So the oxygen is your common denominator when two or more amino acids interact. So we know in the matter state, iron plays the role of the magnet. So that's why two pieces of metal would attract to each other. So iron plays that role. But in a plasma, in the Gans state, oxygen plays that role. So that plays that central role as acts as the gravitational between two amino acids. The hydrogen is dictated by the central sun of our universe, and it's the common denominator throughout our universe. Nitrogen is created through our interaction with Earth and the sun, and it's very specific to this planet. And then carbon, because of its crystal structure, acts as the communicator in the amino acid structure. So when we look at the amino acid structure, oxygen would always be in the middle because it's 16, then we have nitrogen, carbon, and hydrogen being on the outer. Now the interaction of amino acid structure with Gans of elements such as calcium, silicon, potassium, zinc, and iron, this leads to creation of our different complex amino acids, which then gives the plant diversity that we see around us. Now, current science has always taught us, that's the diagram on the left, that we have carbons and then bonding with oxygens and nitrogens with hydrogens, and so that total amino acid structure would then have a field strength of 72. But essentially from a plasma point of view, we would look at it differently in that the center is your oxygen. So there, because we've got two oxygens, that's 32. Then you've got one nitrogen, two carbons, and your two hydrogens. So from a plasma point of view, we still get the field strength of 72, but it's in that field strength. So we've got to sort of look at it from a very different perspective as to what we've been taught. So the stronger fields are always in the center, which would be the oxygen, and the weaker fields to the outside. So together, they create their own Coulomb barrier, and that's where we then have that field strength of 72. So it's the combination of the different fields creates that entity of itself. And it will still have the field strength of 72 as an example to the picture of the amino acid. So now when we have a look at the breakdown of the plants and animals, you can see that we just made up of carbons, oxygens, hydrogens, and nitrogen. And if you notice, it's very small amounts of nitrogen, even for the plants. So it's almost 96%. That's what we're made up of, is just those 3 or 4 elements. So essentially, if we've got, if we look on the left, we have man, so the amino acids interacting with the Gans of the copper or the Gans of the zinc, and we get sort of our muscle formation with the zinc. We look at the emotion of the man. So it's that combination of the amino acids with the different metals. Same as on the plants, when you look at the amino acids with silicon, magnesium, you get the physical structure of the plant, or with the magnesium, you're getting the blood, the sap of the plant. And so one has this whole interaction going on where we're forming the base of your amino acid structure, and then it just depends on what this amino acid structure is going to be interacting with as to the type of different creatures that are created, whether it's plants, man, animals, earthworms. But as you know, then, so every creature on the planet comes from the same source of this nitrogen. So before I go into the details on that one, is there any questions? Okay. Now, one of the statements that Mr. Keshe made was the nitrogen and other fields from the sun interact, and due to the friction, it releases hydrogen or helium. So I decided to sort of have a look at the various structures. Now, bear in mind, this is just, when we're looking at these structures, the way that we've put it up is the way that we've sort of understood how things were in the past. And I think I'm just leaving it as is so that because we are familiar with these, and so we can understand and we can try and get our mind around it. So essentially, hydrogen is, my apologies. Okay, so your hydrogen is 1 proton and 1 electron. Your deuterium structure is 1 neutron, 1 proton, 1 electron. And the tritium is 2 neutrons, 1 proton, 1 electron. So when we have a look at the hydrogen in a sort of plasmatic state, so this is, bear in mind, in the field state. So we have 2 hydrogens. If we have a hydrogen and we're looking at sort of a proton and electron on the left, and then another proton and electron, the way I understood it is the hydrogen on its own is very unstable, so that together they want to find a match and to create the balance. So when they come together, this would be in the field state, then they would create, the fields would merge in a sense, and you create 1 neutron, and what you'd have left would be 1 proton and electron. So essentially, from the 2 plasmatic hydrogens, one forms a very stable deuterium. And it's stable because the field strength of your neutron and then your field strength of your proton and electron creates that nice balance within that structure. So that's why it becomes quite stable. And then when we have a look at helium, we have 2 protons, 2 electrons, and 2 neutrons. Okay. So another way that I sort of looked at this picture to try and understand it is that essentially it's 2 deuteriums, because it's one neutron, one proton, electron, one neutron, proton, and electron. But essentially, together, it would create that field strength of helium itself. So we wouldn't see all the different electrons as we understand now, but it's more in a sense just in the field-based strength. So I needed to look at those to try and understand the makeup of the hydrogen and the helium so that we could see how this nitrogen is essentially the creator and how it might be working. So when we look at, I looked at the nitrogen, and our current science, we would explain it this way, that we've got 7 neutrons, 7 protons, and 7 electrons. And as you see that on the left, we have circled the neutron, proton, electron forms that very stable structure. But as we know, that would essentially be the plasma of nitrogen just in terms of its field strength. Just to come back to that. So the nitrogen, just to repeat that statement again, the nitrogen and other fields from the sun interact, and due to the friction, it releases hydrogen or helium, okay, in that process and creates that energy, essentially, half hydrogen and the helium. So I had a look at carbon. So carbon has 6 neutrons, 6 protons, and 6 electrons. Okay. So when we have a look at the process of the nitrogen to carbon, then it's essentially, if we have 7 protons, 7 neutrons, electrons, which would be nitrogen, carbon has 6. So it's the releasing of the field strength of the deuterium from the nitrogen leads to the creation of the carbon. And essentially, we know that the deuterium was essentially made up of 2 plasmas of hydrogen. So when that process happens, so when we have the process of the nitrogen fields to the carbon fields, it's that release of energy, it's release of hydrogen in that process, which leads us to the formation of carbon, which gives it that release of energy. Then I looked at oxygen, and oxygen says we have 8 neutrons, 8 protons, 8 electrons. Okay. So the nitrogen to oxygen from 7, we need to go to 8. So it's the addition of the field strength of deuterium leads to the creation of oxygen. But I'm thinking that it's more to do with the helium. So it's the helium which feels attached to the nitrogen, and in that process we also get the release of additional hydrogen, because when we look at helium, we can see that it has 2 protons, 2 electrons, and 2 neutrons. So in its combination with the nitrogen to form the oxygen, we also get this release of additional hydrogen fields. And so when you look at that structure there of the 4 elements, you see nitrogen being in the middle, and we get to carbon and we have a release of energy. And if we go from nitrogen to oxygen, in that process, I'm thinking is also the release of the energy. And we know that in the fertilizer industry, we throw in nitrogen fertilizer in the soils, and one then starts to question, is it the nitrogen itself which is feeding the plant, or is it the hydrogen from this process that is feeding the plant? Because plants take up the hydrogen, use the hydrogen as their energy. And that's the source, the food source for plants is essentially the hydrogen. So it's this process which is going on, which is releasing the hydrogen. So as the carbon, oxygen, hydrogen are created from the plasma of nitrogen, now we know why they have that connection and why we have the amino acid structure formation on this planet. And they also have that connection to the principal fields from our sun and the universe, which explains why everything is connected to everything else. So any questions on that? I can go back because it's quite complicated to try and understand.
I have a question, Jim. This is Willie from Norway.
Yes, Willie.
You know, when we add nitrogen to the Earth, would the difference between the matter state nitrogen that's in the Earth and the nitrogen in plasmatic state that's in the air create the hydrogen needed? The field strength difference.
I'm sure it does. It's you know, I'm just trying to get my head around this as to the process and the mechanisms behind it. That it's quite possible.
Yeah,
and
I was thinking about that. You know, it's kind of the same as we do when we try to make something with our ganses. Yeah.
Yeah.
You use if you're going to use one specific GANs to get one specific result, then you use the GANSes in itself as one strength, and then you dry some GANSes to get it in the matter state, yeah?
Yes, you know, it's this, obviously everything comes down to this the field transfer and this interaction of the fields and whether it creates that balance or not.
Yeah.
It's a way of trying to explain it, understand it all.
Yeah, and it's hard. I have my opinions, of course, but then again, I'm never sure if I'm right.
Well, we don't know until, you know, we put this on the table and we can sort of pick it apart, and if it ends up being wrong, then it's wrong, you know, but we can learn from it.
Yeah, of course. So, because the difference in the field strength to get a specific result, the difference needed is very, very little. We tend to want too much. I remember Mr. Keshe said that you need small adjustments to get the result you want. And the smallest adjustment would be the difference between the different states.
Yeah, you know, and it's a lot easier in the field state to make these than in the matter state. I mean, that's what nuclear fusion is all about, is trying to do things in the matter state.
Yeah, and it's the same if we go back to the canopies of the trees you showed in the picture. Those trees of the same make and the same, they're in this balanced, according to each other, in this balanced state. They have this, probably the most similar field strength, yeah?
Yes.
And that creates a specific gap, as with the Ganses.
Mm.
And maybe it's the field strength of those trees are such as they make that gap so big that we actually can see it.
Yes.
And if you introduce other trees with a different field strength, maybe more gravitational, maybe they would, you know, grow into each other in a way. Yeah, because the gap would be smaller, yeah?
Yeah. It would change that, change the condition around those trees. Maybe you wouldn't get that effect.
That's the thing. Maybe if you just put something in the earth, it would be enough to close the gap or make it bigger. Or in the air, of course.
It's all questions. I don't have an answer for you.
No, well, we've got to pose the question and then we can think about it and maybe we'll find the answer.
Yeah. So it's just a couple of thoughts I had when I
saw that here. No, thanks for that.
Oh, you're so welcome, and thank you for letting me speak.
Any other questions?
It's a quiet crowd.
It's a very quiet crowd.
Yeah. Any of you people have any thoughts of what I asked as questions? Maybe.
Jim, it's Brett. Can you just run over that whole thing again, please? Is that possible?
Okay.
Thanks, mate.
It took me a long time to try and figure this out. So yes, I don't expect you to understand it in 10 minutes. So, okay. Okay. So we all understand nitrogen. 7, 7, and 7. Okay. And carbon is 6 neutrons, 6 protons, 6 electrons. So the difference between those two elements is 1 neutron, 1 proton, 1 electron. And we know that that structure is deuterium, being 1 neutron, 1 proton, 1 electron. So the nitrogen losing its field strength of deuterium, or in the format of hydrogen, because if you're looking at small peels coming off, so you're releasing sort of one hydrogen and another hydrogen, but together they will make up that strength of deuterium, and then you get the change from the nitrogen to the carbon. Does that make sense?
Yes, actually. Thank you.
Okay. And then it's just the opposite for oxygen, because oxygen is 8, so it needs 8 and the nitrogen is only 7. So it needs an addition, so it needs extra fields that have to come in. And all it does require is the field strength of deuterium, and then you're looking at, in totality, the field strength of the oxygen, from the nitrogen to the oxygen with the addition of the field strength of deuterium. But I think this one comes from the helium, because when you take a look at the field strength of helium there, that's 2 protons, 2 electrons, 2 neutrons. So if these fields are feeding the nitrogen, in that process, the nitrogen can convert to the oxygen, but at the same time, we are releasing the remaining fields of the helium, essentially become the hydrogen. So the helium breaks down, feeds the nitrogen, and so that we can create the oxygen, but at the same time, we're creating additional energy, which what's left of the helium being hydrogen. So in both processes, from the nitrogen to the carbon and nitrogen to oxygen, it's the release of energy. And I say, when you have a look at the structure in the man and the body and in the plants, I mean, we have a very small amount of nitrogen. So, you know, what happens to that nitrogen? So it's this process going to the carbon or the oxygen, which forms the basis of what we're made up of. And it's during this process that we get the release of the energy in hydrogen. That's all done in a plasmatic state, not in any matter state.
So in a sense, that's why oxygen attracts. And hydrogen or deuterium gives. Am I understanding this correctly?
Because, well, oxygen then becomes that becomes out of the 4 elements, oxygen becomes quite stable, being 8. When you look at what I've read somewhere, sort of the 8 gives you 8 neutrons, and when they balance up, it creates a very balanced structure. So you've got 8 and 6, but 7 means that you have one unbalanced structure of a proton, and so that's why that one becomes the creator. And when you create the oxygen and the carbon, those two become very stable, and then your oxygen acts as the gravitator.
Got it. Thank you.
Any other questions? Brains are steaming. It's just the way I like to work is I have to understand everything. So, even if somebody says something to me, I have to try and break it down to understand the essence of it. It's the same process happens when Mr. Keshe says when there's mercury on the brain. And I was working on that one today to see how that one works. And he says the mercury is changed to gold. And we do this by CH3. And it's essentially the addition of energy to that mercury, which leads to the creation of the gold.
I see Alex has put his hand up.
Okay. So once we begin to understand this process, then we'll be able to begin to understand really what's, how our body and how things are working.
Alex.
Alex?
Put his hand up.
You had your hand up?
Yes. One of the, when you make the Gans and then you put it in the bottle and turn the bottle upside down, you see how the Gans drops down?
Yes.
It kind of gravitates to the bottom of the bottle. And I'm pretty certain in people's mind's eye that they see the Gans as a weighty material that is actually floating through the water and coming down to the bottom because it's being sucked by gravity. I'm just saying that this is probably what they see in their mind's eye. What I've seen in my mind's eye is that the Gans, because of its high reactivity, is actually giving and taking an electron as it's coming down level by level by level, so that this is a continuous process. In other words, it isn't, let's put it this way, when a car goes through the air, people see it as the car is breaking the air to go around the car. What I see is that the car is attracting electrons at the front and emitting electrons at the back, and that's how it moves. So I'm just trying to construct a picture of how the Gans floats down through the plasma water. This accounts for how it floats, and this accounts for how it purifies, because the copper Gans we know purifies water. And it can only do that when it's all in Gans and everything. If there is some kind of chemical reaction and some kind of chemical attraction or some kind of electromagnetic attraction, because the Gans itself is all individual suns and they're all fluffy, So it's not like a filter. It's not like a filter cloth or a filter media or coffee filter. That's not how we purify the water. Where I'm going with this is that what you said is that and it's brilliant what you said. So I see the amino acids as is coming down, where the nitrogen is contributing and forming a deuterium, and then it forms a carbon, and then the helium breaks down and contributes to form an oxygen. The one thing that I'm missing is that the helium has 2 neutrons and the hydrogen doesn't have any neutrons, which by matter state principles would make the helium heavier. And yet we know that the helium is lighter. So that's my question, is how does that happen?
Well, say all this is in field-based. So I'm just thinking that, I'm looking at why Mr. Keshe made that statement of hydrogen and helium. And so, with the addition of helium to the nitrogen, as you say, the helium loses fields, and it can form a stable structure of deuterium that's left, because then what would be left would be 1 neutron, 1 proton, 1 electron. And this could still be a very stable structure, or that could eventually break down further into its basic component of the hydrogen field.
Yeah, when you look at the atomic periodic tables, they lump helium and hydrogen kind of together, and they don't really explain it.
Yeah.
What you've described here is brilliant, because it's a straight arithmetic, and it is absolutely the jigsaw puzzle absolutely works. The motivation is between the deuterium, the hydrogen, and the helium, and so there's something that's missing, because just on the atomic weight alone, as I say, the helium would be falling down. So when is it helium, when is it hydrogen, and what is the motivating factor to cause the reaction? So when the plasmatic energy comes in from the sun and hits the nitrogen, and that begins the reaction, so then there's a cascading effect, and so the oscillation of this cascading effect is producing carbon, and then producing oxygen, and producing carbon, producing oxygen, and it builds up and it draws in, and so that's one oscillating effect. The other oscillating effect is between the hydrogen and the helium. So you're constantly producing hydrogen, helium, and so you've got this Magravs reaction working constantly. So the hydrogen to helium oscillation is more in a magnetic, and the carbon to oxygen oscillation is more gravitational. So and that's the way I would explain it from what you said. I just trying to get my understanding of how how we come up to have a stable helium that is lighter than air.
You see, but I mean, when you look at what our atmosphere is made up of, we don't really have very much. Remember what the concentration of helium was. It's quite small. I don't have those figures anyway.
Except if it forms a dodecahedron, which is really what Gans is, as opposed to a nanostate. So possibly the explanation would be that the hydrogen is more in a nanostate and the helium is in a Gans state.
Lots of questions. It's we have to try and drill down in to find out how this process works. Because once we can understand this process, then it can easily start explaining how everything else is working.
Absolutely.
Oh, for heaven's sake. 0.3%, no. It's parts per million actually, by volume, which is making me a bit confused.
It seems small.
Very tiny.
Other questions or comments?
So, Jim, the relationship between gravitational and magnetical, with the explanation that you gave before, can you try to connect the two for me?
Well, hydrogen is magnetical.
Because it floats around and it can join up to other things.
You know, that's when we know from like we make our CH3, and that's our magnetical aspect. The oxygen being one of the oxides is the gravitational aspect of it. So you get this, you know, so if there's anything that has to flow from one to the other, it's going to be the hydrogen that's going to do it. You know, the hydrogen is essentially the building blocks of the universe.
Okay, thanks, mate. Sorry about the noise of my daughter coming home. Sorry.
Does it answer your question?
Yes, pretty much. I'm starting to kind of get it. But I'm looking at the bigger scheme of things, not necessarily just what you're saying. So I'm thinking.
Yeah. Good.
The cogs are turning. Can't you hear them?
All the way across Australia, yeah.
Okay. Anybody else? Because that's the end.
There we go.
Okay. All right. Now this will be the last of our Gardeners and Growers workshops for this year. We are going to be working on new material, and then we will start with a new series of workshops that will start in early 2018. And we just need to try and do all this, and so we can just have a bit of a gap to get a lot of work done, so that we can then start up again. Because I think we sort of have gone quite fast and with a lot of the information on the plants and the nature and that sort of thing. And so I think we've probably gone too far ahead. So the whole idea is to sort of just stop for a while, and say we'll, in that time, the next couple of months, we'll be creating new material, so that was what basically building up on what we have done already, but to try and create it in an easier format and a more step-by-step process that people can follow, which is specifically relating to the nature and the environment, and how the plasma works in our environment. So I just want to, thank all those who contributed, all the presentations and everything that participated over the last year. We've learned a lot ourselves, just as much as what we've been able to teach a lot of people. Everybody else has taught us a lot as well, so we really learned and enjoyed everybody's participation over this last year. And so we just want to say thank you, and so we can always keep in touch with emails or Zoom if you have questions. But yeah.
And we will be starting as of tomorrow with a brand new basic workshop, which will be on the public Zoom, which is going to be on the normal English Zoom, which the normal knowledge seeker workshop is on, and the other Tuesday workshop as well. So that will take us right through till the end of the year, and then we can start up with something like this again in the future. So please join us for the basic workshops, because I think we can all brush up on our basics again, and it will include some of the agriculture and nature as well.
Thank you both.
Yeah, no, thank you. Thanks, everybody.
What time is that starting, Lisa, tomorrow?
A normal 10 o'clock.
10 o'clock a.m.
Europe, yeah.
Europe time, yeah. Always the middle of the night for you, Alex, sorry.
It's just fine because it's very peaceful.
All right.
Can I just add one thing, please?
Yes, go ahead.
I want to thank you, Lisa and Jim, for the hard work that you've done. This is brilliant. The two seminars that you did, where you associated the metals with the plant and animal life, and this one today, are absolutely brilliant. The one thing I have kept asking is the relationship of the bacteria in this whole thing, and I'm hoping that we get more detail on that in 2018. Today's is great strides. The food for thought on the relationship of the hydrogen, the deuterium, the helium is something that we just going to need some time to absorb, and once we see that in our mind's eye how it's working, I think this is going to end up being child's play, and I think that's the problem. Older people are going to have a lot harder time coming to grips with this, because you've explained it in a totally different way, and frankly, it makes much more sense than the way we've been thinking. So I want to thank you very much for all your fine work.
Thanks, Alec, for all your contribution as well.
And hopefully we'll have lots more insights next year, because we've been very busy working on our aquaponics system, which is no more an aquaponics system and is on transition to be plasmaponics. And we're learning such a great deal of how the plants actually operate. So we'll be able to literally create a thesis on how the plants are working in our system one of these days. So we'll have lots of information. It's just to try and get it completely right so that we know exactly what we're doing, and it's all a process. And as you know, with nature, it's never fast. It can take quite a long time to figure things out.
Can I just ask one more question, please?
Yeah.
Do you grow any water hyacinths in Australia?
Not us personally,
Not us, no.
They are around, yeah.
Yeah, it's just we need a lot of it. A lot.
No can help.
We're a bit too droughty for that here, I'm
Yeah.
afraid. In terms of good scale of anything, because there's yes, you're in permanent drought mode just about, and when it's not droughting, it's flooding. So it's a very severe climate here.
Oh, okay. Well, you're doing great there. I just want to let you know that this summer we've had a tremendous amount of rain. Last year the water level was down about 3 feet over here, and right now it's topped right up. And then for the last week we've had summer. It's been the best weather all year. We've actually hit 30 degrees Celsius.
Okay.
And we've been running here about 22 to 24. You know,
The whole summer.
The whole summer. It's been one of the coldest summers we've ever had, and raining every.
Sorry, maybe I must move to Canada because we just still in spring, but today is like 35 degrees. It's just unreal.
It was 22 last week, and now it's 35, and there was nothing in between.
Yeah, but in about 4 weeks, it's going to be minus 20 here.
Oh, okay.
Then we'll stay away. Thanks.
Yeah. You're welcome. I'll trade you.
Is it the rocket stove or the air conditioner? You got good choices in life these days.
Well, we're going to be busy making heaters.
All right.
So thanks everybody. It's been great. We will start gathering new material for the next load, and please join us tomorrow for the basics. And that will be a 12-part series of basic workshops for all the students. And we also encourage all the private students to please come and ask really pertinent, good questions relating to topic on each little section, so that we can have a really nice, concise set of videos at the end.
Thank you, and let me just tell that in the chat I put a link so you can start studying why you have this extreme weather, because it's not a coincidence. I know people don't like to study this and they think this is crazy, but this is real. I've spent a lot of time on it. So I just sent you a list of patents for weather modification, and nobody patents anything for fun.
I'll have a look. Thanks. Thanks, Eric.
Yeah, you're welcome. Thank you.
All right. We'll call it a day. And thank you.
Thanks, everybody.
Thank you so much.
Keep well.
Thank you.
Jim. Thank you, Lisa, and everybody. I love you.